Alright folks, section 1.8. In this section we're going to introduce you to something called transformations. We're going to use a lot of visuals on the graph to represent how we are changing or transforming functions or points. So our goals, our objectives are to describe and graph the results of horizontal and vertical translations. And translations are a specific kind of transformation. And also describe and graph the results of a reflection about the x-axis or the y-axis, and describe and graph the results of horizontal and vertical stretches and compressions. So basically we're going to do some translations, some reflections, some stretches, and some compressions. So a transformation is simply a change in the position, size, or shape of a figure. We're transforming it into something different. Just like the Transformers, they transform from a car into a robot, or from a robot into a jet fighter. And a translation is a specific kind of transformation. We also call them shifts or slides. So a translation or a shift or a slide is a transformation that moves each point in a figure the same distance in the same direction. It doesn't change the shape of it, just moves all of their locations. So let's start out with some translations. I want to translate this point, -3, 4, 5 units to the right. So I want to translate it. It means I'm just sliding it or shifting it 5 units to the right. So I'm going to start where it is. I'm going to go over 1, 2, 3, 4, 5 units to the right. As simple as that. And then I can read my new points. 2, 4. If we look at what we did with the x value, when I move right or left and I'm translating right or left, all I'm doing is adding or subtracting to the x value. So this 2 is -3, and then I added 5 to move right 5. My new result was +2. The y value remains unchanged when I move left or right, when I'm translating or shifting left or right. So when does the y unit move? When does the y value change, you might ask? Well, if I shift up or down, I'm moving along the y values without changing the x values. So let's shift this point, -1, 3, down 2 units. I'm going to start here and go down 2. Down 1, down 2. My new point then is the point -1, 1. And when I move up or down, when I shift up or down or translate up or down, I'm going to be affecting the y value. So I changed this point from -1, 1, or correction, from -1, 3 to -1, 1. I started at 3, I shifted down 2 units, and I ended up at my y value being 1. Now let's combine. We can do these two things together. I want to shift left 2 and down 4 at the same time. If I start at -3, 4, when I shift left 2, I'm going to go over 1, 2. So now my new x value is going to be, the x value will be -3, left this time, so I'm subtracting 2. My new x value is going to be -5, somewhere along here. Now I'm going to shift down 4, so I'm going to go down 1, 2, 3, 4. And here's my new point. My old y value was a 4, and I wanted to shift down 4, so I took 4 away. My new y value is 0, and that corresponds with where we counted out at. My new point is -5, 0. Let's go back to our point. We'll try it again. I shift left 1, 2, and down 1, 2, 3, 4. My new point is -5, 0. So those are translations. We're literally just sliding across the graph and putting the points in different locations. Now, in the previous slide, it was all individual single points. Let's say I wanted to take an entire graph, a bunch of lines or curves, and I wanted to shift this down to 2 units. Well, we could see that there's a point here, and there's a point here, and a point here, and all along. So all along the lines are points. We could find some key critical points where they're changing, and use those to identify the new location. So a key critical point here is -2, 0. Well, I want to shift down 2 units, so I'm going to go from -2, 0. I want to take 2 units down, so I'm going to change it to -2, -2. Remember, up, down doesn't change my x, it only changes the y. So I'm going to go down 1, 2 here. Here's another key point. I'm going to shift down 1, 2, and then I'll shift down 1, 2. And these are nice because they're all straight lines. I can find this goes down 1, 2. Here's another intersection, 1, 2. Here's an intersection, 1, 2 down. I'm still shifting everything down 2 units, 1, 2. And the end result is going to be the same exact shape, just moved down 2 units. So I can shift an entire graph down 2 units that way. Again, that's translations or shifts, where you're moving every point the same exact number of points. Now another thing we can do, another kind of transformation, is called a reflection. When I reflect, we're going to limit our reflections. We can actually reflect things about a lot of different lines, but we're going to keep it kind of simple in ours and kind of straightforward. We're going to reflect about our axes only. The x or the y-axis, that's the only thing we're going to reflect about. So if I reflect about the y-axis, we have to think about this being a mirror, and we're pivoting around the y-axis. So if I start here, and I were to swing around to the other side, my numbers will stay the same. I still want to be 3 units away from the y-axis, and I want to be 4 units up. So when I swing around over here, my new point's just going to be 3, 4. Now let's look and make sure we understand. When I reflect about the y-axis, which value changed? Well, the y value is going to stay the same, because as I swing around to the other side, I'm not going up or down. I'm moving left or right. And remember, a left or right move has to do with the x value. And when I reflect about an axis, I just take the opposite value of the number that I'm reflecting. Here I was -3. I want to be the same distance on the other side. So now I'm +3. I just multiply the x value by a negative. So if I start off at x, y, and I reflect about the y-axis, my new point is -x, y. Now, I could do the same thing with reflections as I did translations or shifts. If I want to reflect this entire graph, I would find some key critical points. We could find them here. This is -4, -2. This time I want to reflect about the x-axis though. So when I reflect about the x-axis, I want to jump to the other side of the x-axis. When I move across the x-axis, my y values are changing, but the x value itself is staying the same. So we can think about this just rotating up and becoming symmetrical on the other side. Where I was at -4, -2, now I want to be on the other side of the x-axis, -4, +2. And here's an interesting note. If I'm at 0 on the x-axis, when I reflect, I don't move anywhere, because the opposite of 0 is still 0. It's neither positive nor negative. So here I just stay at 0. If I start at -2 though, I want to flip to the other side and be +2, because I'm reflecting about the x-axis. And here again at 0, I would stay there. And now at 4, -2, I would want to jump up to the other side and be 4, +2. So let's see what happens when I take this. Let me use my system here. I'm just going to flip it upside down, and I'm going to shift it up. See where we started? I'm going to reflect it about the x-axis. So I make a symmetrical figure. I just rotated everything up to the other side of the x-axis. When I did that, I changed all of the y values. All of my x values stayed the same. And I took the opposite y values. All right. So remember, when I'm reflecting across an axis, what I like to do is just visually either draw or in my mind see an XY axis. If I'm reflecting or flipping about the Y axis, I'm changing my X value, and I'm just taking the opposite X value. If I'm reflecting about the Y axis, I'm changing the, if I'm reflecting about the Y axis, I'm changing the X value. If I'm reflecting about the X axis, I'm flipping this way. I'm going to end up going up or down. I'm changing the Y value. I just take the opposite Y values. Now, just like a reflection or a translation, we can do another kind of transformation called a stretch or compression. Now, a stretch will always be a whole number, a vertical stretch by a factor of 2, and a compression will always be a number between 0 and 1. Okay? It will always be a whole number, positives, and a compression will always be a number between 0 and 1. So if I were to stretch vertically, when we say vertical, what values are affected vertically? Well, the y values are affected vertically. So here we're affecting our y values. If I want to stretch vertically by a factor of 2, everywhere on this graph, I would take each of these points and go up by a factor of 2. I would multiply them all by 2. Here my y value is 1. My new y value, I'm going to keep the x value, and the new y value is going to be 2 times as much. 2 times 1 is 2. If I go to 4, 2 times 4 is 8. I keep the x value because I'm only stretching vertically. I'm making him taller and skinnier. Just like if you stretched a rubber band vertically, it would get taller and skinnier. I'm going to stretch it 2 times as much. So now, when I input 2, I don't want my output to be 4. I want the output to be 8. Same thing on this side. This output of 1 becomes a 2. I multiply it by 2 because I'm stretching by a factor of 2. And then 4 becomes 8. And this old 8 would be, the new value would be 16. So here this old 8, the new value would go right up to a 16. And we can see that I'm making this taller and skinnier. Now let's look at the origin point though. At 0, 0, if I stretch 0 vertically by a factor of 2, what's 2 times 0? It doesn't change. So if I stretch vertically, this value still stays there. Now let's look at it, let's compress vertically by a factor of 1/2. Again, we're doing vertically, so that tells me it's a y value change. My x values are going to stay the same. Now when I go to the original of 1, I want to compress by a factor of 1/2. If I were to compress or squish this whole thing down, it's going to get shorter and fatter. So if I started at 1, when I compress vertically by a factor of 1/2, it drops my y value down to 1/2 times 1, which is 1/2. It just so happens that it's going to do that over here. When I started at 4, 1/2 times 4 is now 2. So my new y value here would be 2. And here the 4 would become a 2. My old y value of 8 would become a 4. This old y value of 8 would become a 4. My original y value of 16, I'm compressing by 1/2. It's going to come down here and become an 8. This is going to come down from here and become an 8. And now we can connect these, and we'll see that in effect we have gotten shorter and fatter. And those are going to go on forever in that direction. Now it's important again at the origin, I started with a y value of 0, and then I multiplied it by 1/2, so I still have a y value of 1/2. Now I should have coordinated my colors a little better. Let me Let me fix these for you really quick so that this guy should actually match the green letters over there, and this guy should actually match the blue letters over there. So my stretch makes it taller and skinnier. My compression makes it shorter and fatter. And again, when I say a stretch or compression, I have to specify, is it vertical or horizontal? Here it's a vertical. I'm changing the vertical so my y values are affected. All of my y values are being multiplied by 2 to stretch it, and when I compressed it, I'm multiplying them all by 1/2. So we could stretch vertically by a factor of 3, and all I would do is multiply each of these values by 3 and get even taller and skinnier. Or I can compress by a factor of 1/8, and I could get even shorter and fatter. So now let's do horizontal stretches and compressions. Now again, we're going to find some key points that that help define the graph. If I want to stretch horizontally, I'm talking about left and right. So when I talk about horizontally, I'm going to affect the x value. When I stretch horizontally by a factor of 2, I'm going to find all of these points' x values. I'm going to make them 2 times as large. So here, let's start with let's go left to right. Here the x value is -6. But now I want to stretch horizontally by a factor of 2. So what's -6 times 2? It becomes -12. I stay on the same y value though. I'm not changing the y values. I'm only stretching horizontally. So my new point moves from here times 2 to -12. -4 times 2 is -8. -2 times 2 becomes -4. When I come down here, my x value is 0. So 0 stretched by a factor of 2 is still 0. I leave this point where it is. Now I'll come over to this other critical point. I get 5 times 2 is 10. And on this point, I'm stretching horizontally by a factor of 2, so 6 becomes 12. Now I would go back, and I can connect each of these change points that I used to see what the graph would look like when it's stretched horizontally by a factor of 2. Obviously, stretching it horizontally is going to elongate it this way. Now let's try to compress horizontally by a factor of 1/2. When I compress horizontally by a factor of 1/2, I'm going to go back to my original graph again, and I'm going to divide all of my x values by 2 because I'm doing a horizontal compression. It's a change in the x values. I compress horizontally by a factor of 2. A 6 now becomes a -3. -6 times 1/2 is -3. -4 times 1/2, -2. 0 times 1/2 is still 0, so that one doesn't change. -5 times 1/2 becomes 2.5. 6 times 1/2 becomes 3. And now I'm ready to connect my dots. See if it kept a blue line. Good. I'm going to connect here to here, this to this point to this point, and this point goes on out. This point comes on down. Now I have effectively, in the blue, compressed my original graph horizontally by a factor of 1/2. So for right now, we're able to look at these graphs and manipulate them point by point. In the next section, we'll talk about how to do these transformations, our translations, our reflections, and our horizontal stretch and compressions, and vertical stretch and compressions, by manipulating the function notation. But for now, we're just going to talk about doing it with these critical points. Remember, a horizontal change affects the x value, a vertical change affects the y value, and when I reflect about an axis, I need to remember and kind of draw out. I actually just will draw out an x and y axis. If I'm reflecting about the x-axis, I'm changing the y values. If I'm reflecting about the y-axis, I'm actually moving horizontally, so my x values will change. All right.